just a couple of things today. The first one is the normal to a curve. The normal line to a curve at a point is the line perpendicular to the tangent at that point. So what that looks like is this. If you have, some sort of a curve like this, and you draw the tangent line across it. Oh, hang on a second. Thought I had switched that to make a nice straight line. So let's say we wanted the tangent at that point, right? The normal line is just perpendicular to that at that point. And that's it, okay? Normal lines have a lot of applications in optics and satellite receivers and all kinds of stuff like that. So let's take a look. Write an equation for the line normal to the curve f of x is equal to x squared minus 3x plus 4 at x equals 1. So the first thing I want to do is figure out, well, what's the slope going to be? So to save us some time, instead of doing it at A, let's just do it at x is 1, right? So that means that my slope is going to be the limit as h goes to 0 of f of 1 plus h minus f at 1 all over 1 plus h minus 1. So that's going to be the limit as h goes to 0 of 1 plus h quantity squared minus 3 times 1 plus h plus 4 minus f at 1, which is 1 minus 3 is negative 2 plus 4 is positive 2. All over h. Expanding the numerator, we'll have the limit as h goes to 0 of, this will be 1 plus 2h plus h squared minus 3 minus 3h plus 4 minus 2 all over h. So this will be the limit as h goes to 0 of, let's see, we've got an h squared and then we've got a 2h and a negative 3h, so minus h. And then we've got 1 minus 3 is negative 2, plus 4 is positive 2, minus 2 is 0. Oh, well, that's nice. When you do a polynomial and you're finding the slope of the tangent, that should always happen. Everything that doesn't have an h that's in the numerator should drop out. So now I'll just divide. This is the limit as h goes to 0 of h minus 1. And that's negative 1. So this is the slope of the curve. So the slope of the normal is going to be the opposite reciprocal, just be positive 1. So in order to write the equation of that line, we need a point and a slope. We've got the slope. We just need to know what the point is. If you substitute in 1, that's 1 minus 3 is negative. 2 plus 4 is 2. So my point has coordinates 1, 2. And I can do the point slope equation. Y is equal to the y value that I have, 2, plus the slope, 1, times x minus the x value at the point, 1. And again, your book is always going to go ahead and rewrite that in slope-intercept form. Any questions about that? All right. Just a couple of things for you to know. That expression, f of a plus h minus f of a over h, is called the difference quotient. It is the average rate of change of f from the point a f of a to the point a plus h f of a plus h. Graphically, it's the slope of the secant line joining those 2 points. We talked about that yesterday, right? Yes? No, maybe? I guess not yesterday. I guess it would have been Tuesday. Now, when we take the limit as h goes to 0 of the difference quotient, what's happening is the horizontal distance between the 2 points is going to 0, which means that the actual distance between the 2 points is also going to 0. It's the instantaneous rate of change of f at a. Graphically, it's the slope of the curve at x equals a, or we can also say the slope of the tangent line. And frequently they leave off the word line on that. They just say the slope of the tangent at x equals a. Slope of the tangent, slope of the curve, same thing. Because if you have a tangent line at some point to a curve and you zoom in over and over and over again, eventually you're not going to be able to tell the tangent line from the curve. All right. So let's do this. Find the limit as h goes to 0 of f of t plus h minus f of t all over h for the function f of t is equal to 3t squared minus 4 at t equals 2. Notice that's a period, so that's step 1. Step 2, interpret the answer if f of t represents the position function of an object in feet at time t seconds. Okie dokie. So we want the limit as h goes to 0 of, we're at t is equal to 2, so this is going to be 3 times 2 plus h quantity squared minus 4 minus f at 2, let's see, that'll be 4 times 3 is 12, minus 4 is 8. All over h. So this will be the limit as h goes to 0 of, let's see, that's going to be 3 times 4 is 12. And then 3 times 4h is 12h. And 3 times h squared is 3h squared. And then minus 4 minus 8, that's minus 12. All over h. And as I said a minute ago, if it's a polynomial and you're doing this process, everything in the numerator that doesn't have an h in it should drop out, and it does. We're going to have the limit as h goes to 0 of 12h plus 3h squared over h. We can do the division because h is never 0, it's just getting close to it. And that's going to be the limit as h goes to 0 of 12 plus 3h. When h goes to 0, that leaves me with just 12. So let's think about this just a second. If f of t represents the position function of an object, what I have found is the difference in position over the change in time, t plus h minus h. Remember, that always just gives you, t plus h minus t, which just gives you h. So this is the instantaneous rate of change of the object's position at time t is equal to 2. What's another single word for the instantaneous rate of change of an object's position? Close. Velocity. Speed is the absolute value. In this case, the speed and the velocity are the same, but we have to be careful about that. If the object is moving forwards and backwards, then we have to always consider velocity. Okay? So the velocity of the object is 12 feet per second at time t is equal to 2 seconds. Are any of you taking AP Physics? A couple of you? Okay. So you do this in physics. You probably have already done this in AP Physics, yes? That if we take the position function and we'll talk more about this, the derivative, you get the velocity function. Have y'all already done that? Yes? Pardon? A bit? Okay. All right. Well, that is it for today, except for the quiz.